So I'm going to define for you a few things here. First of all, a set is any collection of objects. Okay, very broad and general here. So I have some examples. A set is often described by listing a collection of objects. We call these members or elements of the set. We usually write this as a list of elements using curly brackets. Okay, and you'll see that as we write these. And we denote the full set by a capital letter, so that's another thing we're going to use. So here's 3 examples. You can have set C, which represents the resistors produced in a factory on a particular day. And so instead of, there's a whole bunch, so we didn't want to list them all out individually, so we just wrote a little sentence in the curly brackets that represented all of them. D is probably a set representing a switch. Okay? Switches can be on or off, and so in electronics, if you're looking at those kinds of things, that might be something interesting to look at. And then E is the set of digits. There are 10 digits that make up numbers, 0 through 9, that we use. Now, once you have a set, you can start looking at smaller sets within a set, and we call those subsets. Sometimes one set is contained completely within another. For example, if we have set X here, which is 2, 3, 4, 5, 6, and set Y, which is 2, 3, 6, then all the elements of Y are also elements of X, and so we say that Y is a subset of X. Now, I didn't write it on here, but there is a notation for that, and it would look like this. Y is a subset. It's kind of like a long C for subset of X. But I'm okay if you just write it out at Y is a subset of X. So in exercise 1, we have 3 sets here, A, B, and C. Looking at them, can you see which set is a subset of another? And feel free, yeah. A is a subset of B because if we look at A has the elements 1, 2, and 3, and B also has those elements. And so I'm going to write A, the subset of B. Or you could write it out in words, but this is a little bit quicker to write that. What else? C has elements 0, 1, which is a subset of A and a subset of B. So we could write C is a subset of A, and C is also a subset of B. And something that maybe you wouldn't think of, but you could also say that A is a subset of itself. And any set can be considered a subset of itself, which is pretty obvious, but if I ever ask you to count how many subsets something has, you also need to count the set itself. The empty set and the universal set. Sometimes a set will contain no elements. For example, suppose we define the set K by K is all odd numbers which are divisible by 4. Since there are no odd numbers which are divisible by 4, then K has no elements. And so the set with no elements is what we call the empty set. And we denote it with a 0 and a slash through it. And so if you're already used to writing your zeros that way, because maybe a prior teacher told you, hey, make sure you put a slash through your zero so I know it's not an O. Probably want to get out of that habit now, because typically in mathematics, if you put a slash through a 0, it means no solution or empty set. And so most of us don't do that, but every once in a while I come by somebody that makes their zeros like that. And that can confuse you in the future. On the other hand, the set containing all the objects of interest in a particular situation is called the universal set. And we'll use S to represent the universal set. The precise universal set will depend upon the context, and I'll start pointing that out through some examples. If, for example, we are concerned with whole numbers, then S will be the set of whole numbers, and so on. What's going to be really important to us are three key things. Okay, we're hitting the first one, and that's the complement of a set. And so to know what that means and know how to use that is going to be important for us, because we're going to use complements when we get to probability. So given a set A and the universal set S, we can define a new set called a complement of A. And we're going to note it with a little prime. So A prime is the complement of A. And the complement of A contains all the elements of the universal set that are not in A. So you got to read that carefully. Complement of A contains all the elements of the universal set that are not in A. So what would A and the complement of A have in common? Well, what elements would they have in common? If you read that carefully, none of them, right? Because the complement is all the elements that are not in A. So it's everything else. And so in exercise 2, we'll illustrate this. So A has the elements 2, 3, and 7. S is our universal set, so this is all of them. So we're looking at all the digits, okay? And so if I want to find the complement of A, so I'm going to look at what A has, I'm going to look at what's in S, and I'm going to pick everything else that A doesn't have, and that's the complement of A. So sorry, A prime is the complement of A. And so what would not be in A? What would I include? 0, 1, can't go 2 because 2's in A, 3's in A, but 4's not. 5, 6, 7's in A, so I'm not going to choose that. 8 and 9. So if you take two sets, if you take a set and its complement and put them together, you should get every element in the universal set. Okay. So complement kind of means opposite. Yeah. How about the complement of B? Why don't you write down what the complement of B would be? And what are we getting? B has 0, 1, 2, 3, and 4, so its complement would have 5, 6, 7, 8, 9. Good. So sets are often represented pictorially using Venn diagrams. And so we're going to start using some Venn diagrams and look at some problems eventually that Venn diagrams can help us in visualizing some things or organizing some information here. Here in this Venn diagram, A, B, C, and D represent different sets. The sets A and B have no items in common, and so if two sets don't have any items in common, you won't see those two sets touching each other in the picture. Whereas C and D have some items in common, and so you see that they're overlapping or they have an intersection. And so that matters when you're drawing these Venn diagrams. In the Venn diagram, the universal set is always represented by a rectangle. So you're always going to have a rectangle around this, and you see the S in the bottom right-hand corner. So in exercise 3, we have set A, we have set B, and let's let the universal set, I'll define it as all digits. So digits are just 0 through 9, okay? So that's our universal set. And so let's represent this. Let's draw a Venn diagram with A, B, and S. Okay. So how should we, it matters, should we make these intersect? Should they not be touching each other? Where would I put the circles? Or the ovals, or how are we going to define these? Like, would I do this? Here's A and here's B. Why not? Okay, because they both share some elements, right? So how about this? Here's A and here's B. Happy with that? Okay. So where would I put some numbers? Where would 0 go? Right here in the intersection? Because they both have 0. Where would 1 go? Okay. 2? In the intersection or in the other part? Because both are B, right? So just right here. So 2, 3, and 4 would go here. Where would I put 5? Right here. 6, 7, 8, and 9 here. What about this empty space for A? Did I put anything in there? Okay, so then that tells us that actually A should be just inside of B. So actually it should look like this. Okay, and why is that happening? A is what kind of set? A is a subset of B, and so in the picture it's contained inside of B. Okay. 4 we're going to skip. Okay, so we talked about the complement. There's 2 other key things that we need to look at, the intersection and the union. And next we're going to look at the intersection. Okay. So given 2 sets A and B, the intersection of A and B is a set which contains, so the intersection is a set and it contains elements that are common to both A and B. And here's how we write it. We write it A intersect B, and the intersection symbol looks like an upside down U. Okay. Other times we don't write that, we write A and B. So sometimes you'll see me write A and B, sometimes you'll see me write A intersect B. It means the same thing. So that word and built into that means the intersection. Okay. In a Venn diagram, the intersection is that shaded part where the overlapping part of A and B. Or in the one we just made, our intersection would be where they both share. So it would be this part right here, the 0 and the 1 would be the intersection. So in exercise 5, given A, B, and C, you want to state the set and draw a Venn diagram representing the intersections. So in part A, so I draw a Venn diagram. A and B, so I'm looking at them and saying, hey, do they have an intersection? Well, they both share 3. They both share 5. And that's it, right? And so A and B is a new set with the elements that they both have in common, so 3, 5. So it's a smaller set than what they both were. Okay. The intersections will only get smaller, they'll never get bigger. Okay. And so I'm going to make these 2 overlapping. And put a 3 and a 5 in the intersection. And then what's left in A would be the 4 and the 6. And what's left in B would be the 9, 10, and 15. And I'm just going to put S in the bottom right-hand corner because I'm not sure what the universal set is. Because it's going up to 15, I know it's more than just digits here. Okay. So do that for part B. Write out what the set would be, what's B and C, and then draw a Venn diagram to represent that. Because we don't know what the universal set is, so we'll just put an S. So B and C have what in common? Just 10? Okay. So there is an intersection. They're not subsets of each other, so put 10 in the intersection. Here's B, here's C, here's the universal set. And then B also has 3, 5, 9, and 15. And C also has 4 and 6. Okay. Exercise 6, D is the elements A, B, and C. F is the entire alphabet. And here we don't draw a Venn diagram, just state what the set D and F would be. And what are we getting? Well, D and F has to be something that they both share. And so D doesn't have the entire alphabet, right? So what do they both share? They both have an A, B, and a C. Okay. And remember, the other notation would be this. You could write D intersect F. It means the same thing. New notation for you, so I just want to make sure you see it. Okay. All right, try exercise 7. Find A and B intersect C. Don't worry about Venn diagrams in that one. Okay, so A and B, what do we get? 1, 2, and 3, good. And B intersects C, 2, 3, 4. All right, so we talked about the complement, and we've talked about the intersection. Suppose that A and B have no elements in common. Then their intersection contains no elements, and we say that A and B are mutually exclusive. And so that's going to be a key thing, especially when we get to probabilities. Some events are mutually exclusive. And when that happens, then we're going to have to use certain probability formulas versus when they're not. And so knowing what that means, so they're mutually exclusive when A and B is the empty set. Okay. Recall that that symbol is the empty set. So mutually exclusive sets are represented by separate areas also in the Venn diagram. They don't intersect each other. All right, the last part here, the third part is the union. The union of two sets, A and B, is a set, again, which contains all elements of A, together with all elements of B. So this is different than the intersection, because the intersection only contained what A and B both had. Here it's going to say, hey, take everything in A, dump it in, take everything in B, dump it in. So it potentially can get bigger as long as one's not a subset of the other. So in this one, we write A union B, or it looks like a U, okay, to denote the union of A and B. Also, no, it's denoted A or B. So instead of the and, we use the word or. Okay. Therefore, the elements of A union B are those quantities X, such that X is a member of A or a member of B, or a member of both A and B. And so in these Venn diagrams, they show you two cases. One where they're intersecting, and they say, hey, if we want to represent it, shade everything in this circle and everything in this circle, put it all together, you get your union. In this case, the circles are not intersecting, and so we say they're A and B are what? Mutually exclusive. And so if they're mutually exclusive, the union is still everything in A and everything in B. Okay? You'll never have an empty set when you're finding the union, but you will when you have the intersection. So in exercise 8, we have sets A, B, and C, and find A or B, A or C, B or C. And then I'm going to add a couple more. For part D, I want you to find A and B, A and C, and B and C. So I just want you to contrast the difference between or and right next to each other. So with the or, you take everything in A. So 0 and 1, and dump it together with everything in B. So A already had a 1 and B has a 1, so don't worry about repeating the same element. So if it already has a 1, don't write it again. But now B also has a 2 and a 3. So when you have the or, it just starts to create this larger set than both of them because you're combining the two. Where if we said A and B, what would we put? Just the 1. So it's a smaller set, the intersection. A or C, we combine A and C together and make what? What do we get? Or if I said A and C, you'd put they don't have 0 in common, do they? So actually, we got to put the empty set, which means what? They're mutually exclusive. Okay. If I said B or C, put B and C, B or C together. So B's got 1, 2, and 3. C's got 2, 3, which we already got, 4 and 5. What would B and C be? 2 and 3. Recall that there's no need to repeat elements, like we said here. Okay. Okay. Again, try number 9. Find A or B and find A and B. Okay, A or B is right? So everything in A and everything in B. A and B would be 2, 4, and 6. Okay, try 10. A or B and B and C. And then I'll spice it up for you a little bit. Okay. Start making it more complicated. Right now we're just getting what is the difference between and or, and what is a complement. Okay, A or B. So A, B, C, D, F, that's from A. And anything else that we need to include from B? H. Okay, how about B and C? Huh? F. Okay. All right. So before we go on, I'm going to make up a little problem here. Okay, so say our universal set is A, B, C, D. I'm going to keep it really small. Let's let set A be ABC and set B equal CD. Well, let's just say C. No. Let's do CD, and I need to add one more to our universal set. Let's put an E in the universal set. Okay. Now, to give us a picture of this, I'm going to make a Venn diagram right next to it before I ask you the questions. So we have set A and B. When you make this, it's nice to start in the intersection. What do they both have in common? C. Okay. What does A have that B doesn't have? It's an A and B. What does B have that A doesn't have? And then what do none of them have? E, right? So because that's our, everything in this box is our universe, is what they call it, or universal set. Okay, so what would this be? A union B complement. So you find out, well, what's A union B? And then what's the opposite of that? What's the complement? Okay, so first of all, A union B would be what letters? It would be everything in A, B, C, and everything in B, D. Okay, so that's A union B, but now we want the opposite. So what's left? E. So this would equal just E. Okay. What if I give you A intersect B complement? What's the opposite of the intersection? The complement of the intersection. So first you got to think, well, what is the intersection? What's A intersect B? That's just the C. But I want the rest of it. So I want everything but the C. So what's left? A, B, D, and E. Okay. I warmed you up. I'm going to give you a couple more to try without me. Ready? So kind of on the same level here. A complement union B complement. And then move it up a little bit. A intersect B complement union B complement. Find those two sets. This is practice, getting used to these things. Question. Sorry, A intersect B complement, union B complement. Anybody think they know what that one is? Yeah? A, B, and E? And again, I don't know offhand. I got to check this, right? So I'm going to start on the inside of the parentheses. So A is ABC. Intersect B complement. So B complement is everything that's not in B, but it's in the universal set. So B has C and D, so that would be A, B, and E. Okay. So if I'm looking at the intersection of these two sets, it's what they both have in common, and they both have an A and a B. Okay. So that's the parentheses part. And now I'm going to take the union of that set with the complement of B. So what's not in B is going to be an A, a B, and an E. So if I put those together, I end up with A, B, and E. Good. Okay. There's a bit of logic. You just got to be careful as you go through these, okay? Next question that I'm going to make up is this. This time I'm not going to give you a set. I'm just going to draw a Venn diagram and ask you where I should shade, okay? So if I draw a Venn diagram, here is C, and here's set D, and they intersect each other. I'm telling you that with the drawing, and here's the universal set. And if I want to, where would I shade? If I wanted to shade, let's say C complement. And let me number these regions. There's 4 regions. Region 1, 2, 3, and 4. If I wanted to shade C complement, which of those regions would I shade? Yeah. 1 and 4. So 1 and 4, do you guys agree, are not in C? You disagree? Nope. I'm sorry. Yeah, 4 is, so C, like for example, set C would be 2 and 3. Set D would be 3 and 4. And outside it would be 1. So that would be the complement of C. Good. So now what if I did this? I said, okay, same type of Venn diagram. Here's C, here's D. This is region 1, 2, 3, and 4. And now I want to highlight C complement intersect D complement. Where would I highlight? Okay, so again, I'm getting used to some of this stuff here. So this is saying it's not in C, and it's not in D. So that would be where? Just 1? Is C in, sorry, 1 in what? So definitely here, because this is not in C or D, or C and D. What else? Is 3 in C? It is, so we can't do 3. So it can't be in C and it can't be in D. So just 1. Okay, I'm going to do one more with you. I want to shade the region. C, union. Let's do this. Yeah, C, union, B, complement. And this is region 1, 2, 3, and 4, which one would I color? I'm sorry. Where's B? It should be a D. That's a D, not a B. Where would C, union, D, complement? Which regions would I have to shade? 1, 2, and 3. Well, okay, so I have to shade everything in C. So 2 and 3 for sure. Because it's a union. A union, you take it all and put it together. It's not an intersection. And then everything else that's not shaded, that's not in D. So 1. So the only thing you wouldn't shade is 4. Okay? So the reason I went over those is because if you look at exercise 11, exercise 11 is like what we were doing, right here, without the Venn diagram. Where did I put it? Like this part right here. Okay? This is like exercise 11. And so I encourage you to draw a Venn diagram once, just to put the elements there so you have a nice picture, and then just start working through those. And they're kind of scrunched together. I didn't give you really a lot of space there. So if you feel like you need more room, you could do it on another sheet of paper. And then if you look at exercise 12, you definitely don't have enough space because you're going to draw a Venn diagram for each of the 5. And you're going to draw them so they intersect each other like I was doing with C and D. And you're going to shade where the intersection is like I did here. Okay? And so if you have a highlighter, you could use that. If you don't have a highlighter, you could just lightly shade with your pencil. Okay? And then the other one that I'm going to give you to try is number 15. 15, this is very similar to what we were doing. I don't want to say too much yet. I'm going to go more in detail how to do these tomorrow. It's not too complex to start on it though. And so here it says among 35 children, 23 say they enjoy playing soccer. That's like set A. 13 say they enjoy football. That's like set B. 5 children were in both these categories. How many do not enjoy either sport? And so your answer needs to be either, it's multiple choice, so you know if you're getting something off or not. So I want you to try 15 as well. So your homework really is just 11, 12, and 15. And so I'm going to stop there and let's work on that.